Good day guys, it's tutor engineer here. Today we'll be doing trigonometry, particularly looking at graphs. So let's get on with it. In the diagram below, the graphs of f of x and g of x are drawn for the interval minus 180 to 180 degrees. Then you have point A, you have point B, 2 points on the intersection of f and g. So the first question is, write down the period for g. So here is g, the sine graph. So the period is the length of full revolution. So this should be the period where the graph completes one cycle. So for graph g, that would be 180 degrees. So that's straightforward. And then the second question is calculate the value of k. So k is the y-coordinate of point A. So let me just write it 6.2.1 over here. So we can use either graph f or g to calculate the value of k. So I'll use graph f. So since it's much more simpler. So graph f is y is equal to tan x. So remember, this is your graph f, it's just tan x. So you realize that the value of x at point A is 60 degrees, so I'll replace y is equal to tan 60 degrees. So now we have a situation of a special angle. Tan of 60 is root 3. Okay, so that's the value of k. You can conclude that k is root 3. There you go. And then calculating the coordinates of B. A is point B. Point B is the mirror reflection of some sort to point A. So you realize that a distance from 0 to where point A is 60 degrees. So we'll use the same measurement. Even here, where graph G is 0, we'll move 60 degrees this way. So when we do so, we'll say minus 180, and then we'll just move backwards by 60 degrees. That will give us 120. So yeah, so here we'll write minus 120 as the x coordinates of B, and then the y coordinate is going to be the same as the value of k. So that's going to be root 3. And then write down the range of 2gx. So 2gx, that means you'll be multiplying the graph of g of x, which is already 2 sine of 2x. Okay, so that will give us 4 sine 2x. So here the range is going to be the value of 4. So it's going to be minus 4 to 4. Those are the values of y. So we can say y is the element of minus 4 to 4. So that is it with the range. And then let's go to 6.4. For which of the values of x will g of x plus 5 minus f of x plus 5 less than or equal to 0 in the interval of minus 90 to 0. So we're basically focusing on this interval here. This is the point of focus, minus 90 to 0. So let's just simplify it. So g of x, this plus 5 here, it means the graph is shifting. Is it to the right or to the left? Yes, you got it. It's shifting to the left, even though it's positive. So let's just simplify this. We can rewrite this as g of x plus 5. Then we'll take f of x to the right hand side. It will be positive f of x plus 5. And we can further simplify it in terms of now g of x is less than or equal to f of x, since you are more familiar with this. So where is g of x? So there is g, then there is f. So this is the condition that says g of x is less than or equal to. So it's applicable for this hatched area here, where g of x is just below f of x. So the distance from 0 to point A is 60. The same way here, when you go to the left, the value of x here is going to be minus 60. So we're looking at the x values between minus 60 and 0. So that's the condition, minus 60 and 0. But since we have to shift the graph by 5 units to the left, so we will have minus 5, then minus 60 on this side, then you have x, then 0 minus 5. So if you like, you can rewrite this as for the sake of the space, I'll just write below here, that's going to be minus 65, and then x, and then minus 5. So that's it. And then now let's go to the last question, 6.5. Determine the values of p for which sine of x times cos of x is equal to p will have exactly 2 real roots in the interval minus 180 to 180. So let's just simplify this. In this format, it doesn't really look familiar to us, but we're able to rewrite it in a way that's familiar to us. I'm just going to take you back to this formula. Hopefully you can remember this formula. So I'm going to use this formula. So you kind of have on the left hand side something which looks like this. And then we can simplify this to that. Basically, that's what you're going to be doing. So going back here, that means this will be the same as half sine, then you have to write 2x if you're going to simplify it in that format. And then the graph of half sine 2x looks something like this. Remember, our interval is between 180, minus 180, all the way to 180. And it kind of shrinked, right? So that's going to look something like this on the right hand side until 180. Similar on the left hand side until minus 180. So the amplitude is going to be 1 over 2. And then here, the lowest point is going to be minus 1 over 2. So basically, the value of p will be the value of y, for which we have 2 real roots. Now, the value of p would be the value of y. So I'm just going to write here a dotted line, which is horizontal. You can see here, that's when I'll have a root here. And then also here I'll have the intersection. That means I'll have a root, another root here. So that condition will be met if p is equal to 1 over 2. And then also in the same interval, you'll realize that here below, also if p is minus 1 over 2, it's also going to be intersecting the graph twice, giving 2 roots. That's the first root here, then the second root is over here. So this is also true when p is less than minus 1 over 2.